We've seen, oh, what about the direction of ion migration through the salt bridge? Remember, the salt bridge has positives and negatives in it. What ions are going to flow down into the anode? Yes. The zinc is going to oxidize. It's going to put Zn positive 2 in here. So that means if there's nothing flowing down the salt bridge, positive 2 would build up, or positive charge would build up. That can't happen. So the negative ions from the salt bridge flow into the anode. And over here, where the silver ions are coating onto the bar, we're losing positive, so positive has to enter in from the salt bridge on that side. So we've hit the direction of ion migration to the salt bridge, identify the cathode and anode, those are done, and give the overall balanced equation. Is this equation balanced? At first it looks like it, but it's actually not balanced. The atoms are all balanced, but the charges aren't. Positive 1 on the left, positive 2 on the right. How can we balance this thing? Well, we could add electrons, but let's not. You could break it up into half reactions, but let's not do that either. Let's just recognize that this has lost 1 electron, that has lost 2 electrons. So if I just put a 2 in front of this and a 2 in front of that, that would take care of it. Now my atoms are still balanced, but now my charges are balanced too. Yes?
Wait, where do we are now?
Yep. The battery lab, no, that's not going to be a write-up. But that electrolysis lab, yes. And yeah, you'll have to sketch it.
I feel bad for those potatoes we stabbed.
Oh no, they're good. They're good.
You know what the galvanic cell, what would happen to the galvanic cell if he heard about this? He would be galvanized. Father.
Is it funny today? Eddie? No, you don't have to show anything about the balanced equation in here. Just show what's the reactants and what the products are both. That's fine. You don't need to show it being balanced at all. All right, so I have a nicer drawing of the same picture here. This is what I would be looking for in your sketch. Make sure you include the overall balanced equation, but all the components are here. Now on Monday, we're going to review this, but it's going to start on Monday. Don't write this down yet. This is where we begin. I'm going to give this to you and say, here, you draw this now, and include these 5 things. This is what we're up to on Monday.
So is this going to be like one question?
So we're done for today?
Yes, that would be like number 1.
Mr. Moore, are we done for today?
Right, exactly. Yep. So all the 5 things that I asked you to do, each of those were. Yep. All right, just one other thing, and that is about the battery lab. Now, because we have had to push everything back by a day, the battery lab will not be on a Friday, it'll be on a Monday. That actually gives you 2 weekends to consider what you're going to do and then gather your materials. That helps. In fact, I feel very good about having that thing right after a weekend rather than right before a weekend, because you don't really know so much what you're going to use for your battery lab until you've started to do some problems and get the hang of what these problems include. Did you break too many? Are you kids?
1.
Oh, yeah. Okay, so anyway, with regard to the battery lab, what you're trying to do is come up with reactants that will make as high a voltage as possible. You want to try to maximize your voltage. So you're going to have to use the table in the book. If you want to use maximum voltage, you'd probably go to the thing that reduces the best, which is fluorine, and the thing that oxidizes the best, which is lithium, and use those. However, there are a few things that are banned substances. Fluorine, I don't think you're going to find fluorine, so I'm not worried about that. But lithium is not that hard to find. So unfortunately, lithium is very reactive and it presents more of a danger than I'm interested in here. So we're banning lithium.
No, Mr. Moore,
Yes.
Can we extract fluorine from toothpaste or something like that?
Yeah, you can.
The fluoride ion is only 0.15% of your toothpaste.
But if we're that try-hard for the extra credit.
Yes, you can use it on a fluoride toothpaste only. No other source of fluoride except for or fluorine gas except
What if
for
I find it on Amazon?
No.
They'll ship it over with their drones or whatever, carrying the gas.
So anyway, that's what we're up to. You'll need to come up with a cell and bring stuff in from home. I'm not providing any materials for using for oxidizing or reducing. The only thing I provide is glassware, porous cups, platinum, of course. We have plenty of platinum.
Dang, where did you find that much from where?
Oh, no, we have plenty. And I'll have a voltmeter so that we can test what the voltage is. If you're the highest voltage in the class, then for the lab, you get a 15 out of 10. I've been telling you all year I didn't know what extra credit was, but I've just learned.
Oh, so you'll
I'm,
be giving it for the rest of the year from now on, right, Mr. Ward?
Yes, that's right. So yeah, highest voltage in the class is 15 out of 10, and there are even extra credit points for second and third place. If you're the grand champion battery maker and you have the highest voltage in all 6 hours of this class, then you'll get an 18 out of 10 for your.
We can get like over 100%, over like 20%.
It's too high.
No, me, Bill, and Jinsu, we
All
got
right,
this.
you can cut us off there, Raul. Thank you very much for.
I got all three of those right here.
No, wait.
Yeah, I
You
guess.
gotta screw around with somewhere with it. I didn't do anything.
Potato clock, it's right on there.
Go faster.
No, wait. I was.
You want to turn that thing around?
Can I plug it into my socket? I think I'll make it work.
Can you what?
Can I plug it into my